Hey everyone, in this video we'll be solving this problem that involves concepts of friction, relative motion, and toppling. So in this problem we have been given three blocks A, B, and C whose masses are given, and the coefficient of kinetic friction between these three surfaces are different. As you can see, the coefficient of kinetic friction between block A and B is the least, which means the acceleration of A will be the least and the A will move towards the right fastest in this case. So all the three blocks are given the same velocity u towards the right. So after some time, as A moves faster, after some times relative to B, A reaches a point after which it topples about the block B, right? And we are required to find that time t at which that happens. Okay, so and for that purpose, we need to find the accelerations of block A and block B. So for that, we have to draw the FBDs. So beginning with the FBD of block A, as the block A, we know it's moving faster as compared to block B, right? Because the friction here is lower. Friction coefficient here is lower. So the friction will act in the opposite direction to relative motion. And we know the normal reaction here is going to be mg. So the friction force, the magnitude of kinetic friction, is going to be mu by 4 times mg. So the acceleration of A is determined to be mu g by 4 towards the left. Now drawing the FBD of block B, we know the same friction force will act towards the right. Similar to the previous case, the velocity of block B is going to be greater than the velocity of block C. Therefore, we can say the friction acts towards the left in block B. And now the normal reaction here would be simply the sum of weights of block A and block B. So it will be m plus m by 2 times g, which is 3 by 2 mg. So the friction force there, mf dash, would be the friction coefficient times the normal reaction, which would be 3 by 4 mu mg. So as you can see, the f dash is greater than f, which means the acceleration of B would be f dash minus f divided by the mass of block AB, which would be mu g towards the left. So now we have determined the acceleration of block A and acceleration of block B. So now the question is, when will the block A topple about the block B? And the answer to that is when the line of action of the weight of block A passes through this pivot point O, that's the point about which the block starts to topple. So just after that, the block moves an amount of dx towards the right, it will topple about this pivot point. Initially, the block A was here, and the length of block A is L by 4 and the length of block B is L by 2. So the center has to cover a distance of half of L by 4, that is L by 8, plus another L by 4 distance, before relative to block B, Okay, so the displacement of center of mass of AB is going to be L by 8 plus L by 4, which will be 3L by 8. The relative acceleration of block A with respect to B is going to be the difference of their accelerations, which will be mu g minus mu g by 4, which is 3 by 4 mu g towards the right. Okay, so as we have determined the relative acceleration, and the displacement of the center is going to be 3L by 8. And as both of their initial velocities are the same, so the relative velocity will be 0. And now we can just use s equals ut plus half at square and substitute all the values in it to get the time to be 3 seconds. So if you guys enjoyed the solution, please like and subscribe. And that was it for this problem. Thanks for watching, guys.